and then outputs the transformed input to the next layer. With a convolutional layer, this transformation is a convolution operation. We'll come back to this operation in a bit. For now, let's look at a high-level idea of what convolutional layers are doing. As mentioned earlier, convolutional neural networks are able to detect patterns in images. More precisely, the convolutional layers are able to detect patterns. Well, actually, let's be a little more precise than that. With each convolutional layer, we need to specify the number of filters the layer should have, and we'll speak technically about what a filter is in just a few moments. But for now, understand that these filters are actually what detect the patterns. Now, when I say that the filters are able to detect patterns, what precisely do I mean by patterns? Well, think about how much may be going on in any single image. Multiple edges, shapes, textures, objects, etc. So one type of, quote, pattern that a filter could detect could be edges in images. So this filter would be called an edge detector, for example. Some filters may detect corners, some may detect circles, others squares. Now, these simple and kind of geometric filters are what we'd see at the start of our network. The deeper our network goes, the more sophisticated these filters become. So in later layers, rather than edges and simple shapes, our filters may be able to detect specific objects like eyes, ears, hair or fur, feathers, scales, and beaks even. And in even deeper layers, the filters are able to detect even more sophisticated objects like full dogs, cats, lizards, and birds. To understand what's actually happening here with these convolutional layers and their respective filters, let's look at an example. So say we have a convolutional neural network that's accepting images of handwritten digits, like from the MNIST dataset, and our network is classifying them into their respective categories of whether the image is of a 1, 2, 3, etc. Let's now assume that the first hidden layer in our model is a convolutional layer. As mentioned earlier, when adding a convolutional layer to a model, we also have to specify how many filters we want the layer to have. A filter can technically just be thought of as a relatively small matrix for which we decide the number of rows and number of columns that this matrix has. And the values within the matrix are initialized with random numbers. So for this first convolutional layer in this example of ours, we're going to specify that we want the layer to contain one filter of size 3 by 3. Now when this convolutional layer receives input, the filter will slide over each 3 by 3 set of pixels from the input itself until it's slid over every 3 by 3 block of pixels from the entire image. This sliding is actually referred to as convolving. So really, we should say that the filter is going to convolve across each 3 by 3 block of pixels from the input. To actually illustrate this, I'm going to use an example that Jeremy Howard used in one of his lectures for Fast AI. His example really gave me a lot of insight behind what was going on within a convolutional layer, so I'd like to share that with you all too. I've also linked to his lecture in the description of this video. So here we have our matrix representation of an image of a 7 from the MNIST dataset. The values in this matrix are the individual pixels from the image. Alright, so this is our input, and this input will be passed to a convolutional layer. As just discussed, we've specified this layer to only have one filter, and this filter is going to convolve across each 3 by 3 block of pixels from the input. So here's our 3 by 3 filter of random numbers here. When the filter first lands on the first 3 by 3 block of pixels, the dot product of the filter itself with the 3 by 3 block of pixels from the input will be computed and stored. This will occur for each 3 by 3 set of pixels that the filter convolves. So look, we would just take the dot product of the filter here with this first 3 by 3 block, and then we'd store it over here. Now we slide to the next 3 by 3 block, take the dot product, and then store the value here. If we look at the formula for each of these cells, we can see that it is just indeed the dot product of the filter with each 3 by 3 section of pixels from the input. So here we have this first value is the dot product of this input with this filter. And then if I click on another random value over here, we can see that this value is the dot product of the filter with this input. So after this filter has convolved the entire input, we'll be left with a new representation of our input, which is going to be made up of the entire matrix of those stored dot products we got from the filter. This matrix of dot products is going to be the output of this layer and is represented here. This is what will then be passed to the next layer as input. And this same process that we just went through with the filter will happen to this new output with the next layer's filters. Now, this was just a very simple illustration, but as mentioned, we can think of these filters as pattern detectors. So we can't really observe any specific patterns